Hey everyone, we're going to examine 6 parent functions that we're going to be using in class, starting with a linear function. Many of you dealt with these, or all of you dealt with these in Algebra 1. The equation for the linear function is f of x equals x. And you probably remember some linear functions like y equals mx plus b with a different y-intercept and a different slope. But this is the parent function. This is one with a y-intercept of 0 and a slope of 1. It's also just whatever you put in for x comes out for y. If you think about it, plug in a number for x, get out a number for y. So we're just going to use a table to represent this. The numbers we're going to use for this table are -2, -1, 0, 1, and 2. And like I said, you plug the number in for x, you come out with a y. So our x value is -2, y value is also -2, x value is -1. Y value is also -1. X is 0, y is 0. X is 1, y is 2. X is 2, y is 2. So to plot down the graph, you just make those points. And as you might remember, a linear function is a line, right? Linear function, linear line, a straight line that either goes up from left to right or down from left to right, or it's vertical, or it's horizontal. No matter what, it is just a straight line. And the y-intercept depends on your b, and the slope depends on the number before the x. So let's take a look at the next one. This is another one you saw in Algebra 1. This is quadratic. F of x equals x squared. What that's saying is whatever number you put in for x, you square it to get y. So our table is going -3. Put a -3 for x. Remember, you're always putting the numbers in parentheses when you square them. Come out with 9. -2. 4. -1, 1. 0 is 0. 1 is 1. 2 is 4. 3 is 9. So all we really need to do right now is make sure that we can get our table down, understand what each graph's going to look like, and how we could draw each one. So let's plot all our points now. We have the first one, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And a quadratic graph is called a parabola. It's a U-shaped graph. Looking like this. You could also have an upside down parabola. If you started with a negative number, your parabola could go up or down, left or right, or grow or shrink. So the next one we'll look at is a cubic function. If the quadratic function is squared, the cubic one is cubed. So whatever number you put in, you do it to the third power. Our table is -2, -1, 0, 1, and 2. So we put -2, always in parentheses, cubed, you get 8. -1, sorry, you get -8, my bad. Cubed, you get -1. 0 cubed, you get 0. 1 cubed, you get 1. 2 cubed, you get 8. Just remember that if you cube a negative number, it stays negative because that's technically -2 times -2 times -2, which is -8. So we'll plot this graph, and it's going to look different than many of the graphs we've ever seen. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So it's this type of graph. Starts low, ends up high, makes this little curve here near the middle. And that is your cubic graph. Now let's look at the square root graph. Square root is the inverse operation of square, so it's not surprising that we're putting in perfect squares for x, that our x values that we're going to use are 0, 1, 4, and 9. So you put in the number, you take the square root of it. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So it's easiest to use perfect squares for your x values when you're doing the square root function. The other thing you need to be careful of, there are no negative x or y values in the parent function. Now it may shift later and might bring numbers into the negatives, but in the beginning this parent function has no negatives. So we'll put 0, 0 as our starting point as a closed circle to start our graph. 0, 0, 1, 1, 4, 2, and 9, 3. And it'll extend out to the right, but it will not go to the left or below. And if you look at it, like I was saying, this is the opposite of the quadratic. It's actually half of the parabola on its side, if you could imagine the other half. But those numbers would not exist because it'd be square rooting a negative. Cube root, which if square root is the opposite of quadratic, which is squared, cube root is the opposite of cubic. So our numbers are the perfect cubes that we found before. Negative 8, negative 1, 0, 1, 8. Notice there are negatives in this graph. Cube root of negative 8 is negative 2. You're essentially taking this graph, reversing the x and y. Just like this graph reverses the x and y's for the quadratic graph. So using that same notion, the cube root of negative 1 is negative 1, cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2. We'll plot those on the graph. Negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2. And look, it's that funny looking graph again, but on its side. Just like we had the parabola on its side, we now have our cubic graph on its side. So the last parent function we'll look at here is the absolute value one. As you may or may not know, whatever number you put into the absolute value sign will come out positive. It's the distance from 0. So in our table, negative 2, negative 1, 0, 1, 2, you put in any number, it's going to come out positive. So negative 2 is 2, negative 1 is 1, 0 is 0, 1 is 1, and 2 is 2. If you put in negative 1,000, it's the same as 1,000 because they're the same distance from 0. This is going to be a V-shaped graph. And we'll just plot our points and take a look at that. So this side's kind of like f of x equals x, our linear function, but this side's only positive values, so it's a little bit different. And that's it. Make sure you take down all these notes.